Welcome to my presentation. In this presentation we shall see how to perform matrix multiplication. So to perform matrix multiplication we have some properties to look for, and then we will try to understand these properties and then be able to apply them to solving some simple example problems. So let's write the properties. If we have matrices of this type, matrix A, if A is a matrix and B is a matrix and C is a matrix, and if these are of size m by n, and if C is any scalar quantity or C is a constant, then we can write the following properties. 1. If we have three matrices multiplied together like this, A times B times C, and then no matter which way we combine them, the result is going to be the same. Let me write the right hand side as well, and then I'll explain this. A times B times C, and every one of these matrices has elements within them. For some reason, let's say we multiplied B times C first, and put this, we multiplied B times C first, and then multiplied the product of that to matrix A, we would have a value. We would have a resulting would be another matrix. With that quantity, what we get would be exactly the same as if we were to multiply on the right hand side matrix A times matrix B and take the product of that and then multiply to matrix C. So therefore this is what is called the associative property of multiplication, and this is very similar to what we have seen in basic algebra. The second property we want to know is as follows. The second property is, if we have matrix A and if we were to, for some reason, we have matrix C, matrix B and matrix C within parentheses like that, this is the same as this is the same as what we have seen in basic algebra, which we call as the distribution property. We're going to distribute the matrix A, which is outside of the parentheses, to every one of the matrix inside the parentheses, and the way we can write that is as follows: matrix A times matrix B plus matrix A times matrix C. This is what is called the distribution property, and in the only difference between the basic algebra and linear algebra here is in this matrices is we have elements in these matrix, and therefore the elements when we look at AB, the product of AB and then product of AC, and then when we simplify the terms on the left hand side in this manner, in that combination manner, the result is going to be exactly the same. The third property we want to keep in mind is this: if we have a constant C, and if that were to be multiplied to matrix A and matrix B and let's say matrix C as well, we could distribute the constant to one of the matrices, not all of them. There is no positive sign or negative sign separating the matrix A, B and C. It is matrix A times matrix B times matrix C. We can write this one as, we can either distribute the constant to matrix A and then write the rest of the matrices next to them like that, or distribute the matrix C, or distribute the constant to matrix C like this: matrix A times C times B, or distribute it to every one of the elements inside the matrix B and then write the matrix C like that. Or we can distribute the constant to matrix C, distribute the constant to matrix C and then just write matrix A and B adjacent to them like this: matrix A times matrix B times C times matrix C like that. Okay, all of these are possible, and these are some of the properties of multiplication of matrices. So we will use these properties to be able to solve some simple examples. In my next presentation, we shall look at how to do matrix multiplication for a 2 by 2 matrix.